Hello, dear students in grade 8. This is a mathematics lecture in our lessons in math, and it's a very, very, very important lesson for this year and next year. I want you to watch this video very well and to write notes, the rules that you have in this video as notes, to study, understand, and memorize these rules to be able to apply them directly. The title of our lesson is Remarkable Identities, Expanding, Simplifying. What are the objectives of this lesson? Number one, as a reminder from last year, what's an algebraic expression, a monomial or a term, like terms or like monomials, addition and subtraction of like monomials, multiplication of monomials. All objective number one we have seen last year in grade 7, and I will remind you again of this objective. Also, the second objective is from last year. Expand or develop an algebraic expression using one of these two rules. M into A plus B equal MA plus MB, or inside here we might have a minus. The second rule, M plus N into A plus B, which is MA plus MB plus NA plus NB. We'll talk about these in our lesson. The new thing in this lesson is expand or develop an algebraic expression using remarkable identities. The three remarkable identities are very important. After you understand them, you should memorize them. Whenever you see this form, you apply the rule directly. So A plus B, all of it squared. So this is red. A plus B, all of it squared. It is A squared plus 2AB, 2 multiplied by A by B plus B squared. The second one, A minus B, all of it squared, is equal to A squared minus 2AB plus B squared. The last one, A minus B into A plus B equal A squared minus B squared. The last objective number 4, how we find the numerical value of an algebraic expression after developing or after expanding. As a reminder, what's an algebraic expression? It is a collection of letters called variables or unknowns and numbers organized together using operations. So in an algebraic expression, we have three things. We have numbers, we have operations, addition, subtraction, multiplication, division, and we have variables or unknowns denoted by letters. For example, the algebraic expression f of x. In this algebraic expression, we have the variable x. So we have 5x plus 2y times 3 minus 6. Also, we have the variable y. E of a, so we have 4a squared minus 2a plus 7. This is an algebraic expression having only the variable a. Each term in the algebraic expression is called a monomial. If we look at this algebraic expression and I ask you, how many terms do we have? The terms are separated either by minus or by a plus. So 4a squared is term number 1. We have a minus. So now we start with term number 2. Minus 2a is the second term, and the plus 7 is the third term. Each term has a sign, has a number, and it might have a variable. If we look at the term plus 7 or minus 6, these terms has no variables, so they are called fixed or constant terms. Like terms or like monomials. Which terms or which monomials we call them like or similar? These terms have the same variables, the same powers or exponents, but they have different coefficients. For example, 2xy and minus 8xy are like terms. Here we have xy, here we have xy. I don't care about coefficients in similar or like terms. For example, a squared bc cube, 10a squared bc cube. Here we have a squared bc cube, a squared bc cube, so these are like or similar terms. 9x4 and 5x squared. Here we have x, here we have x, but since we have different exponents, here we have 4 and here we have 2, so our monomials are not like. These are unlike terms or unlike monomials. Also down here, we have unlike terms or unlike monomials. How we find the numerical value of an algebraic expression? We will be having an algebraic expression with a variable or variables in it. We will be given a value of the variable. So what we do is, it is the result obtained when replacing the letters or the variables or the unknowns by given numbers or values and performing calculations or operations. For example, if we are given an algebraic expression 3x minus 7, and we are given a value for the variable is x, which is x equal 4. So we should find the value of this expression in numbers. What we do is we replace each x in the algebraic expression by the given value 4. So this x, we replace it by 4. Why did I replace it between parentheses? Since the variable is multiplied by 3, so the number should be multiplied by 3. So now I perform calculation using PEMDAS. I have multiplication of 3 times 4 and I have minus 7. Since multiplication is stronger than subtraction, so we multiply first. 3 times 4 is 12 minus 7, the answer is 5. So 5 is the numerical value of the algebraic expression if x is equal to 4. Another example, x squared minus 2x plus 5. This is an algebraic expression. The given value of x is minus 2. Now we should replace x by minus 2. Since x has an exponent, also we replace it between parentheses. So we replace minus 2 square. Minus 2x also, since x is multiplied by negative 2, so we replace it between parentheses, negative 2, and we write plus 5. Now, according to PEMDAS, we have exponent, negative 2 squared, so we say negative 2 times negative 2 is 4, so we write 4. Now, negative 2 is multiplied by negative 2. Negative times negative is positive, and 2 times 2 is 4. And we write plus 5. So now 4 plus 4 plus 5, so we get the answer, which is plus 13. It's very important to know that in an algebraic expression, we can only add or subtract like terms or like or similar monomials. How? When we have like terms or like monomials, we add or subtract the coefficients, we mean the sign with the number, and we keep the variables with their exponents. 2xy plus 6xy. This term and this term are like, since here we have xy and here we have xy. So we say 2 plus 6 is 8 and we keep xy as it is. Negative 5x squared minus x squared. So we say here x squared and here x squared. So both are like, we can do operation. Minus 5 minus 1, we make it on calculator. So the answer is minus 6 and we keep x squared as it is. 3xy plus 5x squared y. These two terms are unlike, since here we have x and here we have x squared, so we keep the answer as it is. We cannot add unlike terms. We keep them as they are. Product of signs. How do we multiply signs? These are rules. Positive times positive is positive, negative times negative is positive. So when we multiply same signs, always the answer is positive. When we multiply different signs, positive times negative or negative times positive, so the answer is always negative. How we multiply monomials? A monomial times a monomial means sign times sign, coefficient times coefficient, or number times number, variable times variable. If we are multiplying same variables, we keep the variable and we add exponent. If we are multiplying different variables, keep the variables as they are. As examples, 3x times 2x squared y. We start positive times positive is positive. 3 times 2 is 6. X times x squared. We are multiplying same variables. Here the exponent is 1, here the exponent is 2. So we write x and we add 1 plus 2 is 3. Here we do not have y, here we have the variable y, so we keep it y. Minus 5x squared times minus 4x cubed. Negative times negative is positive. 5 times 4 is 20. X squared times x cubed. Same variables, we keep it x, and we add 2 plus 3 is 5. Expanding or developing an algebraic expression means is to get rid or remove parentheses in the algebraic expression by multiplying. So we will be given an algebraic expression with parentheses. Our answer will be an algebraic expression without parentheses. We should follow these rules. These are the same rules, but inside we might have a plus, we might have a minus, and this is a rule. So we have a one for all rule and we have an all for all rule. What's the difference? A one for all rule, we might have a parenthesis multiplied by something before it. M into A plus B means M is multiplied by A, it gives MA. M is multiplied by positive B, it gives positive MB. The second rule, M is multiplied by A, it gives MA. M is multiplied by negative B, it gives negative MB. Don't forget, these two rules are called one for all. As examples, we have many examples here. The parentheses might be multiplied by a minus, so the minus is multiplied by everything inside. The parentheses might be multiplied by a number, so we multiply the number by everything inside. It might be multiplied by a coefficient also, and the parentheses might be multiplied by a monomial or like this monomial. You can apply all these rules. The second rule is called the all for all rule. We will have two parentheses multiplied together. So m plus n is a binomial multiplied by another binomial, which is a plus b. We start multiplying. M times A is MA, M times positive B is M positive MB, N times A is NA, and N times B is NB. This is the all for all rule. And here you have lots of exercises. Let me talk about these examples. X plus 3, all of it squared. This means the binomial is multiplied by itself 2 times. So x plus 3 into x plus 3. So we apply the all for all rule. After we get our answer, we should reduce the answer. We look for like terms to add or subtract them. Plus 3x and plus 3x are like terms. They gives us plus 6x. So this is our final answer. Also, please apply these examples to understand well. Now, the new rules of this year in grade 8 for expanding and developing an algebraic expression, these are called remarkable identities. We have 3 rules. You should memorize their form to know when to apply these rules. Before, we were be given and a parenthesis, all of it squared, or a parenthesis, all of it squared. Inside, sometimes we have a plus or a minus. We have written this A plus B into A plus B, or A minus B into A minus B. Now we will stop doing this. We will expand these parentheses, which has square on them, either a plus or a minus, using one of these 2 remarkable identities. So whenever you have a parenthesis square, you look inside. If you have a plus, you should apply this rule. So A plus B, all of it squared, means A squared, whatever here we have, we make it squared, plus 2AB means 2 multiplied by A multiplied by B, plus B square, whatever you have here, you make it square. Let's make an example. X plus 1, all of it square, means here I see binomial. Inside we have a plus and a square. So we apply the first remarkable identity, since this looks like the first remarkable identity. So x for me is A. I need A square, so I write x square, plus 2, I write 2. I should multiply A by B. What's A? It's X, so I write X. What's B? It's 1, so I write 1. So 2 times X times 1 plus. What's B? It's 1. I need B squared, so 1 squared is 1. Now X squared, 2 times X times 1. 2 times 1 is 2 times X is plus 2X plus 1. This is our expanded answer. You have another example here which you can apply. Now the second remarkable identity, A minus B, all of it square, means A square minus 2AB plus B square. These two rules are similar, but when you have a plus, the second monomial should be positive. When you have a minus, the second monomial should be negative. Also, you have two examples here which you can practice and apply. The second remarkable identity, we will be given two parentheses multiplied together. Here, we no more apply the all for all if we have a plus in the first parenthesis or a minus in the second parenthesis, or a minus in the first parenthesis or a plus in the second parenthesis. But here we have A and here we have A. Here we have B and here we have B. So as you can see in the first binomial, in the second binomial, we have the same terms or the same monomials. That's why we apply the third remarkable identity. So the answer is A squared minus B squared. For example, if we have x minus 3 into x plus 3, so since we have negative positive, the same terms, we apply this. What's A? It's x. I need A squared, so it is x squared minus, what's B? It is a 3. I need B squared, which means a 3 squared, which is a 3 times a 3. The answer is 9. Also, we have two other examples which you can apply. As I said, this lesson is very, very important. And as you can see, all what we have in this lesson are rules. So you should memorize these rules to apply them directly. Please watch this video well. And after you watch it, please, if you have any answer, you can contact me directly and I will answer all your concerns. Thank you.